before we jump into today's material? Are you all ready to start? Yes? Okay, so let's start with this. So last class we tried to define the inverse functions, right, for the first three trig functions, sine, cosine, tangent. And we said that in order to define an inverse for sine, we first have to restrict the domain. I said you need to remember that this is the domain restriction for sine. And then we can define the inverse. For cosine, in order to get an inverse, we're going to have to restrict it between 0 and pi, right? Not negative pi over 2 and pi over 2, but 0 and pi. And then we can define the inverse. And then tangent was a lot like sine, except that you don't include the two endpoints, all right? So that's what we established last time. And then we were trying to evaluate these inverse functions at different values, right? Some of them we did using the unit circle. Some of them we had to use our calculators, right? And then I talked about the cancellation property, which is kind of a dangerous property because it can be misused. So I wanted to go through this again and give you just a few more examples to make sure you understand this. So the cancellation property says that if you put a function together with its inverse, they should basically kill each other off. So if you plug x into sine and then take that answer and plug it into the inverse of sine, whatever you plugged in should just come out. This was that whole car wash idea, right? So it goes through this like loop and comes out unchanged. And this is true, but there's like certain conditions that this is only true when certain conditions are met. So let's start with these, the ones in blue first, all right? Okay, because these are the easy ones. If you ever have two functions put together, like sine and its inverse, cosine and its inverse, tangent's inverse, where the sine, the cosine, or the tangent are on the outside, right? So the inverse function is on the inside of the original function. Make sense? Sine inverse is inside of sine. Cosine inverse is inside of cosine. Tangent inverse is inside of tangent. So if that's ever the case, then this answer, you don't have to even think about it. This answer should just be x. As long as the x value you're plugging in is between -1 and 1. Here, as long as this x is between -1 and 1. And for tangent inverse, it doesn't matter. This is always true. Like you don't even have to ever think about it. So let me show you that like this, okay? So if I do sine of sine inverse of, let's say, a half, okay? That answer should just be a half. And the reason why is because the x that we were plugging in was between -1 and 1. And so this is defined, right? You can only plug in numbers between -1 and 1 into the inverse sine. So as long as I do that, the answer is going to be a half. The only time this would be an issue is if someone gave you this. Sine, let's say they did sine inverse of, what was it? We did 3, right? It was 3 or 4 or something like that. Like if we did that, this would not be equal to 3 because this 3 is outside the domain, right? But so as long as this number is between -1 and 1, you can do this. And that's the same for cosine, right? This one works the same as the one above. So if I did cosine of cosine inverse of, let me put in here something like -0.37. What would that be equal to? -0.37, right? As long as this number is between -1 and 1. But I could run into an issue if someone ever tried to trick me and get me to do something like cosine inverse of 4, right? That would be not 4, right? That would be what? Undefined. Okay, so these two would be undefined. Now for tangent, this one, tangent of tangent inverse, this one you can never screw it up, okay? Because no matter what you plug in, okay, no matter what you plug in, the answer is going to be whatever you plug in. So give me any number, it doesn't matter what it is. -6, the answer is -6. Give me, 100, the answer is 100. Give me a billion, the answer is a billion. So for tangent of tangent inverse, there's no way to get it wrong, okay? So I always, ask my students to just remember that if the original trig function's on the outside, then for tangent you're always good. For sine and cosine, just make sure that the number being plugged in is between -1 and 1. All right? Then everything cancels, everything's great. The bad situation is this one, because, or this, all the ones in red. Because the only way that this is ever true is if this x lives in here, right? So if it doesn't live in here, we have to do more work. It's not like here. You know how over here, if it was outside -1 and 1, we just said it's undefined? That's not what happens here. If we pick an x outside of this, we still can get an answer. We just have to work hard to get it. All right, so I want to give you an example of that. Let me erase this over here. I'm going to give you 2 examples of the top one. And we did this last time. I'm just trying to make sure we're all like okay with it. So for this, let me give you 2 examples. First one, sine, inverse is on the outside. Sine, let's go pi over 12. So for this, I just have to make sure that pi over 12 is between -pi over 2 and pi over 2. What do you think? Is it? Yeah? Yeah, it is, right? This is not a common angle, right? But I definitely know it's between, this is pi over 2. -pi over 2 is this way. And pi over 12, well, this is pi over 2, so pi over 4 is here. Pi over 12 is somewhere like right down here. It's a really small angle. So definitely it's between -pi over 2 and pi over 2. So my answer should just be pi over 12, right? No problems. But if I give you something like this, sine inverse of sine, I'm going to make sure I give you an angle that we recognize. Sine of 3 pi over 4. This is not 3 pi over 4, right? So remember from last class how to do this? What did I tell you all to do? Yeah, figure out what this is first, right? Just figure out what that is. Go to your unit circle, and you're looking for the y coordinate at 3 pi over 4, right? So this right here is the y coordinate at 3 pi over 4. Here's 3 pi over 4. What's the y coordinate there? Root 2 over 2. So this really becomes sine inverse of root 2 over 2. Right? That's what that becomes. And now you start the whole problem over. And now it's like, just imagine I gave you this problem, right? So what you would do is you would start that out by saying, all right, I'm talking about the inverse sine function, so I must restrict the domain, right? I have to restrict the domain. I'm not allowed to look over here anymore. And this is asking me the question, at what angle is the y coordinate root 2 over 2? But in this picture right here, right? In this picture, not in this one, in this one. So where does that happen? Where's my y coordinate root 2 over 2? Right here, right? At this angle right there, which is pi over 4. So this isn't 3 pi over 4. The answer is actually pi over 4. And we have to do it that way for all the red ones. We have to do it that way. Yes.
Or do you want us to have the answer in radians?
Well, if the problem is given in radians, you should probably answer in radians. Yeah. Okay. We're going to move on to 8.2. So last class we talked about the inverse of sine, the inverse of cosine, the inverse of tangent. Today we're going to talk about the 3 remaining inverse functions, right? We have secant, cosecant, cotangent. Those are the other trig functions, right? So those should each have inverses as well. So let's discuss those. There's good news and bad news here. And the bad news is we have to talk about 3 more functions, 3 more inverses. That's bad news, right? There's more for us to have to keep track of. That's bad news. The good news is that because they're just the reciprocal functions, the domain restrictions will be the same. So, for example, if f of x equals, let's start with cosecant x. Cosecant x. That's the reciprocal of which function? It's the reciprocal of sine, right? That's 1 over sine. So if I want to have an inverse function, right, a function that undoes this one, it's going to have the same domain restriction that sine had when we made the inverse for sine. So what was the domain restriction for sine? Negative pi over 2 and pi over 2. So if we start with this function and we make sure that the x is between negative pi over 2 and pi over 2. Now there's a little bit of a tricky part here. I can't include these. And that is because what is sine of pi over 2? So go to pi over 2. What's sine? 1? Yes? Okay. So are we going to have a problem or no? Are you going to have a problem at pi over 2 or not? Think about this. Can you plug pi over 2 into these? I think I'm going to draw a picture. Hold on, let me do it this way. I'm leaving this as an open question right now. Do y'all remember how to draw a cosecant? I hope you do. How do we draw a cosecant? We start by drawing sine, right? We draw sine first. Let's go backwards as well. And then everywhere it hits the x-axis is a vertical asymptote, right? Like this. And then the cosecant function is just these little, like almost parabola looking things, right? What's in black here? That's f of x equals cosecant x. Y'all agree? Is this a function? Does it pass a vertical line test? Yes? Does it pass the horizontal line test? No. Right? So we have to restrict the domain. So we're going to restrict it. In order to make it, to have an inverse function, we have to restrict the domain. We're going to do the same domain restriction we did for sine. We're going to go from pi over 2 here, and then negative pi over 2 here. And we're going to restrict, so I'm going to cut this off like this. This is all gone. And then I'm going to cut off here. That's all gone right there. Okay? So now is it a function and pass the horizontal? Does it pass both of them? The black function? Yes? Passes vertical, passes horizontal, right? I think, is someone saying no or no?
Oh, it's because the blue.
Ignore the blue, right? The blue's not really there. That was just to help us graph it, right? So it's just the black function there. That passes both the vertical and horizontal line test, yes? Okay, so if I'm going to have a restriction, if I'm going to restrict it, do I include pi over 2 and negative pi over 2? So are these points part of this graph? Yes, they are, right? So I do want to have them there. But is there any point that actually causes a problem here? 0, right? So do y'all see that this is not okay for me to just say x between negative pi over 2 and pi over 2? I also can't have x be what? 0, right? Right? If x is 0, then I have an asymptote here. Okay, so I need to modify this domain restriction. You have a question or no? You're just thinking it through? Okay. So how could I say that? I want everything from negative pi over 2 all the way up to 0, and then everything past 0 to pi over 2, right? So I'm going to change this. I'm going to write it in a different notation. I'm going to say, and the domain is going to be from negative pi over 2, negative pi over 2 with a bracket to 0, parenthesis, union 0 to pi over 2. That's a different notation than I've been using, right? I've usually just put like x's between here and here. But because I have two intervals, I'm going to have this split up interval notation. Remember, the brackets mean to include the endpoint. The parenthesis means don't include the endpoint. So everything from pi over 2 all the way up to 0, don't include 0, and then everything from 0 to the right to pi over 2. Yes? So as long as I restrict the domain in there, right, then I should be able to define the inverse. Then the inverse of this function should be the cosecant inverse function. So this is the function that undoes that function. Let's do a problem. Let's actually do a problem where I ask you for cosecant of something, and then you can see this really isn't as bad as it may look right now. So if I ask us to find cosecant inverse of 2, let's find cosecant inverse of 2. What this is really saying to you is this. At what angle is cosecant equal to 2? Right? A picture of what this is saying is this. Cosecant goes from here to here. The answer is 2, right? 2 gets taken back to what angle? Remember, angles go into the trig functions, numbers come out. We want to take this number back to the angle it came from. So at what angle on the unit circle is cosecant 2? Pi over 6? Why are you saying pi over 6? It's the reciprocal of 1/2, right? So you have to realize that 2 is really 1/2 flipped over, right? And cosecant is sine flipped over. So if you're looking at cosecant being 2, this is equivalent to saying where is sine of some angle equal to 1/2. I'm going to put angle here because I don't know what the angle is, right? At what angle, theta, is cosecant 2 is the same as saying at what angle is sine, the reciprocal of that, which is 1/2. And you said pi over 6? Everyone agree that pi over 6? Why not 5 pi over 6? Why not right here? Domain restriction, right? Or domain restriction. We're not allowed to look over here. So we just want to look here. That's 1/2 right there, right? And so the reciprocal of 1/2 would be 2. Got me? Let's do another one. We don't need this. What about cosecant? Let's do cosecant of 1. So this is really saying sine of what angle is what? Or sorry, not sine. Cosecant of what angle is 1, right? That's what this is really saying? This is really saying cosecant of what angle is 1. But that's really saying sine of what angle is what? The reciprocal of 1. What's the reciprocal of 1? 1 still, right? So this is really saying sine of what angle is 1. But you're only allowed to be in this domain restriction, right? So where is that happening? Sine is the y-coordinate, right? Sine is the y-coordinate. So where is that happening? Pi over 2, up at pi over 2. Right there. How about this one? Do you have any questions right now? How about this one? What is cosecant inverse of 4? So this really means cosecant of some angle has to be 4, right? That's what that really means? Yeah? But that really means sine of some angle has to be the reciprocal of that, which is 1/4, right? Do we know that? That's not a common one, is it? Okay, so since it's not a common one, that means we're going to need what to solve this problem? Or calculators, okay? Now, does your calculator have a cosecant inverse button on it? No. Does it have a sine inverse button? Yes. So somehow we need to use the sine inverse button instead of the cosecant button, cosecant inverse, because we don't have a button. So what I'd like for you to do is think about how this problem right here is equivalent to me asking you this. Isn't that what this means? Sine of some angle is 1/4 really means sine inverse of 1/4, right? This returns an angle. We're trying to figure out what's this angle? What's the angle, right? What's the angle that gives us 1/4? That's exactly what this question asks as well. So you type that into your calculator and it's going to give you your answer. It's either going to be in degrees or radians depending on what mode you're in. So somebody give it to me in degrees, somebody give it to me in radians. 47, thank you. And in radians? Anyone do it?
0.25.
What is it? 0.25, 0.25. That's in radians. Remember I told you don't need to write radians, but I'll write it just so we're clear. So this is a little bit of a tricky problem, right? Because cosecant inverse of 4, first thing we did is we said, okay, what does that mean? It means cosecant of some angle is 4. Well, what does that mean? Well, that means sine of some angle is 1/4, the reciprocal. And we look at that and go, shit, I don't know anywhere on the unit circle where the y-coordinate is 1/4. It's not a common point. So then what we have to do is say, well, we're going to need our calculator. Unfortunately, we don't have that key on our calculator, but we do have the sine inverse key. So all we do is we take that and we look for the sine inverse of its reciprocal. You see, that's all. At the end of the day, that's all we did. We took the reciprocal of that and then did sine inverse instead of cosecant inverse. And that returned the angle. Got it? How about this one? What's cosecant inverse of 1/4? Doesn't exist. Why? Yeah, because this is really saying, we'll just get straight to it over here. This is really saying sine inverse of 4, right? But this is like the question we did a while ago. This is really saying sine of what angle is 4. And sorry, sine can't go past 1, or you can't. It has to be between -1 and 1, right? So this is not going to work. Now you would know that if you type this into your calculator as well. If you type that in, you'd get error or something. I don't know what it would say, domain error, something like that. So this would be undefined. So if you want to take anything away from this, like the big picture you want to take away from this is this. If you're asked for cosecant inverse of something, the first thing you do is convert it over to a sine of some angle is the reciprocal of that, and you see if you recognize this off the unit circle. If you do, then you're just going to go tell me what the angle is. If you don't recognize this, then you're just going to switch it over to this sine inverse and use your calculator. Okay? We have the exact same game when we do the next inverse function for cosine. Or, for secant, right? Secant is the reciprocal of cosine. So secant should have an inverse. So we're gonna set that one up now. If f of x is secant x, right? Then the inverse of that function would be the secant inverse function. What do y'all think about the domain restriction for secant? How do we need to restrict secant so it has an inverse? Well, what was the secant's 1 over cosine, right? So what was the restriction that we had for cosine when we wanted to have an inverse? 0 to pi, right? 0 to pi. So you think about this. If this is really 1 over cosine, and I'm going to restrict myself between 0 and pi, is there anywhere where I'm going to have a problem and get division by 0? What would make cosine, at what angle is cosine 0 here?
Pi over 2.
Pi over 2, exactly. At pi over 2 we have an issue, don't we? If we try and plug pi over 2 in, cosine of pi over 2 is 0, and you get 1 over 0, which is undefined. So just like we had a problem a minute ago with the cosecant, we do have a problem here. We're going to go from 0 to pi over 2, and then union from pi over 2 to pi. It's okay to include the two endpoints, 0 and pi, but you can't include pi over 2 or else you're going to have an issue. So I'm using 0 and pi because that's the way we restricted cosine. Let's do a problem. This is going to work pretty much exactly the way this just worked for cosecant. It's going to be the same thing for secant inverse. So what is secant inverse of -2? So first thing I'm going to do is I'm going to say, all right, well, this is really asking me to figure out what angle I plug into secant to get -2. Right? What angle do I take secant of to get -2? And secant is the reciprocal of cosine, right? So this really means cosine of what angle is what? -1/2, right? The reciprocal of that. Do you know anywhere on your unit circle where which coordinate? The x coordinate, right? Because we're talking about cosine. Where the x coordinate is -1/2? Where's that happening? Right there, good, 2 pi over 3. And you did it in radians as well, that's good. That angle right there, right? What about this angle down here? Isn't the x coordinate also -1/2? It is, but our domain restriction, right? We are only looking between 0 to pi over 2 and then pi over 2 to pi. So we're only allowed to look from here to here and then jump over that little vertical line and then there to there. Can't look down the second quadrant, third or fourth quadrants. So the answer is 2 pi over 3. Try this one. What's secant inverse? Yeah. What's secant inverse of -1? So I'm going to run through this same thing again. This is really asking me, where is what? Secant of some angle, right? We want to know where that's -1, right? But that really means, where is cosine of some angle equal to the reciprocal of that, which is still -1, right? And then that's saying, where on the unit circle is your x coordinate -1? And you can only look between here and there, skipping over the pi over 2. So where is it? Pi. So the answer is pi. Secant inverse of 0. Go through the process. That really means what? Secant, right, of some angle needs to be 0. But secant is the reciprocal of cosine, right? So this is really saying, where is cosine of some angle equal to, ooh, shit, hold on. 0 is the same as 0 over 1, right? Do the reciprocal of that, and what do you get? Undefined, right? That's undefined. There's a problem. There's a problem. I think the easiest way to see this is if you think about what the secant function looks like. Secant looks like this. I'm going to draw it real quick. Remember, it's not this graph. That's your cosine. It's all those little humps like this, right? That's what is this, that. And I'm asking you, when is this secant function 0? So when does it hit the x-axis? Never does, right? It's all these little humps up, or not, it's the u's that go up and down. They never get close to the x-axis. So you should have no solution here. So you have to recognize that when you try and flip 0 over, it's undefined. So this is undefined. You'd get an error on your calculator if you try that. Undefined. Let's try secant inverse of something that we're going to need a calculator for. So how about secant inverse of negative 23? So I'm just going to keep playing this game, right? This really means secant of some angle, right, is equal to negative 23. And that really means that cosine of some angle is what? The reciprocal, right? Negative 1 over 23. And I don't think I know that, right? I don't recognize that from the unit circle. So since I don't recognize it, now I'm going to need my calculator, but my calculator doesn't have a secant inverse key. What it does have, though, is a cosine inverse key, right? And I want to use cosine inverse because we're talking about cosine and secant, right? They're reciprocals. So this really translates to what question? What on my calculator? Cosine inverse of what? Negative 1 over 23. Right? That's what it translates to. And then, I don't know, you can give me that. You're going to have two answers, one in radians, one in degrees. What do you get? 92? Yeah, 92.5. That's your degrees, right? And then, what is that in radians?
1.61.
1.61 radians. Are y'all catching on to this? You understanding? We have one more inverse to go, and then we're going to start doing something kind of weird. Kind of really weird. Let's talk about what's left? Cotangent, right? So if cotangent of x, if f of x equals cotangent of x,